You're listening to WMPG 90.9 Gorham, Portland, community radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, very good.
Bernie is our professor of the astronomy lab at USM and our local protector of the night skies here in southern Maine. Reach out to us at WMBG Scientifically Speaking at gmail.com or on Twitter at WMBG Sci Speak. Bernie,
Yes.
could you let our guests know, or listeners know, what is up in the night sky for this coming week?
Yes, okay, good. I'll do that. So today would be Friday, December 4th. So you're going to have a waning gibbous moon. It was full moon back on the 30th when we had that partial lunar eclipse, which we don't know how that's going to turn out yet because we haven't seen it yet. I don't know if the weather was good for that or not. So it's a waning gibbous moon, which is good. It'll come up after, maybe around 11 o'clock at night. So that's fine, but the planets are getting closer. Jupiter and Saturn are getting really interesting. They're less than 2 degrees apart. And after about another week from now, they're going to be within 1 degree. And then on the winter solstice, they'll be 1/10 of a degree apart. So that's the closest they were in like 800 years. And even for the rest of the month, they're still going to be within 1 degree right until the end of the year. So they're going to just get really close, pass by, and then going to get close on the other side. So that's the main thing to watch for. Mars is still nice and bright. It's brighter and bigger than usual. Still looks nice and red, kind of orange, not really red. You can still see some features on it if you have a telescope. And the moon, the other night I saw it was nice. It was pretty close to Mars. And thinking, of course, that we're going back to the moon maybe in as little as 4 years. And then we're planning to go to Mars within 15 years. That's kind of neat to see the two together and knowing that we're going to go. We've been to one of them already and we're going to the other one fairly soon. So that's kind of what's going on right now.
Awesome. Thanks, Bernie.
Mm-hmm.
And if you can take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So today's show is called Close Call Craters, and Bernie really wanted me to announce that specifically. But we're going to be talking about asteroids today, asteroids that did become meteors, and how we detect them, or at least try to detect them earlier. So there's so many objects in our solar system, so many asteroids that could be coming right at us. And we do have something called ATLAS, it's an acronym, so ATLAS, and it stands for Asteroid Terrestrial Impact Last Alert System. I feel like they tried really hard with that acronym.
They always do.
But essentially, it's an asteroid impact early warning system, and it was developed by University of Hawaii and NASA. And it's essentially two telescopes. They're about 100 miles apart in Haleakala and Mauna Loa, which they both scan the whole sky several times per night and automatically searches for moving objects. So it can recognize asteroids by detecting objects in motion against a more or less fixed background of stars and galaxies. And asteroids typically move, this is what they said, 30 seconds of an arc an hour. Does that sound about right, Bernie?
Yeah, depending on their distance from us, the angle that would make.
Right.
They're certainly noticeable within an hour, yeah.
So this system, the two telescopes, they'll take 4 images of each part of the sky, 12 minutes apart. And then the computer system can actually analyze 250 gigabytes of data per night, and it essentially makes some detailed search of the images after the 4th one. And you can actually find, you can see these images of asteroids that Atlas has found. And you can essentially see, a star-like object moving across the pictures in kind of like a flipbook fashion. Mm-hmm. And so this computer can also compile a list of all these objects that appear to have changed either in position or brightness. And then it can figure out if it's likely to be an asteroid or some other astronomical phenomenon. I think they've discovered like supernova and some other objects as well, not just asteroids. And so if Atlas suspects that an object is an asteroid, then the computer can compare it to our existing asteroids that we know of. And if there's no match, it can calculate both the orbit and distinguish if it's a main belt asteroid, which is not dangerous, or a potentially hazardous object, which is an asteroid that might go through our orbit.
Yeah.
And so these calculations can actually happen within minutes, which is really cool.
Hmm.
And some other facts are that Atlas can detect a 100-meter diameter asteroid at a distance of 40 million kilometers and a 10-meter diameter asteroid at a max distance of 4 million kilometers. And so for asteroids that might be approaching Earth at about 20 kilometers per hour, 3 weeks is about the most amount of notice that we would get for that 100-meter asteroid, and 2 days for that 10-meter asteroid. And 10-meter asteroids can still be quite dangerous, but I feel like in general they tend to vaporize. They're more likely to vaporize, but it is.
Or break up like the Chelyabinsk.
Yeah.
That was 56 feet, so that it broke up.
Yeah. And I think 10 meters is roughly 30 to 40
30, a little over 30 feet.
Yeah. So now that we have this understanding of how we can detect asteroids, and this is relatively recent. I actually don't know how old Atlas is.
It is fairly new. I had the date, but it's been around just like 5 years or something. So yeah, exactly 5 years actually. So Atlas already found 536 near-Earth asteroids, plus 57 potentially hazardous asteroids. So they do cross our orbit, so as long as we're not there at the same time, we're okay. But they're crossing over, so it could be a problem. So that's like 600 right there. Then it found 53 comets already and 7,156 supernovae in other galaxies. And then you can add these numbers many more times with NEAT and with linear. Some similar telescopes, which are important for our listeners to know about also. NEAT, so that's another acronym. It's a little bit easier. It's Near Earth Asteroid Tracking System. And then there's another one called Linear, Lincoln Near Earth Asteroid Research. So the Lincoln Labs and MIT set that one up. And each of those has discovered hundreds of comets. And Atlas is interesting because there's 2 comets up there right now that all of our listeners can see if you have just a pair of binoculars. They're about 8th magnitude. There's one called Atlas, actually, and it can be found in the winter hexagon. It's just out of Orion, heading up into Orija. And you can see that in the evening sky. I haven't looked for it yet myself, but I will. The moon's kind of bright right now. But when the moon gets a little bit less bright, we can look for that. And there's another one in the morning sky in Virgo, around near Venus, at about 4 in the morning, 4:30 in the morning. You can see that. And that is also called, it's actually called Erasmus, but an astronomer, Dr. Nicholas Erasmus, using Atlas, because a human still has to scan through all the images they got. So he got credit for finding it, but the Atlas telescope actually found it. So 2 of those comets we can see right now. 2 of those 53 comets it's found in just 5 years.
Wow.
Year, one every month.
Yeah. We have a couple of asteroid coverage for you. And the first one is on asteroid Bennu. Asteroid Bennu is a target of the OSIRIS-REx spacecraft mission. And that left back in 2016, right?
Yep, September 8th.
Yeah. So what else, what's special about asteroid Bennu?
Oh, yes. Okay. Well, it is very special because it is one of those potentially hazardous ones. It's not going to hit us right away, but it might a few hundred or a few thousand years in the future. But so they picked it carefully to study with actually getting a sample from that asteroid. It's been done before, but it hasn't really been brought back because they had landed something on an asteroid that didn't really work right. So it kind of toppled over, and it gave us some data, but not really what we wanted. And it wasn't going to bring anything back to us. So this one will, and that just happened October 20th of this year. So the mission, the OSIRIS-REx, actually sent down a little spacecraft that kind of just skimmed over it. It's called tagging, like kids when we play tag. So it tagged the asteroid, and it formed a little tiny explosion. So and it scooped a little cup into it. And there's some images online that you can see how that happened. So it only lasted like a few seconds. So it's kind of a safe way to do it because they didn't have to land, and it could maybe not come back up, or it could have landed improperly like previous times. So it got the sample. Everything's good. It's being brought back. and we're going to get to look at it in September of 2023. So
2023.
just about exactly 3 more years, we can see what it is. And it'll be really exciting stuff because it's like a time capsule of the original formation of the solar system. We'll learn so much more about how planets formed, probably something about the solar nebula. Of course, we know roughly what's on an asteroid, but they're all a little different. Some of the water on Earth could have come from that. We'll do all the different ions and all the different things that we can figure out from having a physical sample of an asteroid. So that's pretty special.
That's pretty awesome. Yeah, and asteroid Bennu was actually discovered in 1999.
Mhm.
I learned, and it's an Apollo group asteroid. It's also got a diameter of 1,600 feet, so it's pretty big. And so
Yeah,
could
it's
be
pretty big. You
potentially
wouldn't want that to
dangerous.
hit us.
Yeah. Do we know when it'll make its next, like, near close
Um,
call?
yeah, good question. It's not that big in orbit. It's 220 million miles away now. It's just two AUs. So asteroids and comets in those orbits, might, I don't know, have a 10-year period or something.
Yeah, yeah. So I did want to go through kind of a vocabulary check for our listeners because I learned these and it was actually really interesting. So near Earth objects, near Earth asteroids, that's what we're talking about today. And there are main belt asteroids. So I mentioned that a little bit earlier, where main belt asteroids are, that's essentially the band of asteroids between Mars and Jupiter. And asteroids from that belt are too far from us, so they're not really considered to be potentially dangerous.
You're between Mars and Jupiter.
Yep. And then there are the Amor asteroids, which the orbits approach but do not actually cross Earth's orbit. They're further from the sun than Earth's orbit and generally lie between Earth and Mars. They're kind of unlikely to hit Earth, but we still pay attention to them. And then there's the Apollo asteroids, which is what asteroid Bennu is. And an Apollo asteroid their orbits cross Earth's orbit. And they spend most of their time outside of Earth's orbit, and they're somewhat likely to hit Earth. And then there's the Aten asteroids, ATEN, whose orbits also cross Earth's orbit, but spends most of their time inside of Earth's orbit. So does that make sense? And they're more likely to hit Earth. And so there were some stats that kind of just broke down the asteroids. About 54% of asteroids are Apollo asteroids. 37% are Amor, which is between Earth and Mars, and then 8% are Aten. But Aten orbit asteroids are also really difficult to see, so these numbers are probably meaningless. And then lastly, there is another category called Atira asteroids. That's ATIRA, which don't cross our orbit and are closer to the sun than the Earth.
Oh,
So those are the four types of asteroids, which I thought was kind of cool. They're all A's.
yeah,
Um,
I never heard of some of those. Yeah.
yeah. And so most asteroids are believed to originate from the asteroid main belt. They like drop down to lower orbits or because of like some, I don't know why, but they might like collide with another asteroid or maybe comets or comets from the outer solar system that might have been captured when passing close to a planet. So asteroids could originate from those two sources, and it's estimated that about 40% come from captured comets, and then the rest from the asteroid belt. So those are some fun facts. Okay, so I also wanted to talk a little bit about Bernie talked about asteroid Bennu. Um, that one is not predicted to hit us anytime soon, right? But it's just a
Yes,
potential
potential. It's
hazard.
nice. One of the Apollo ones. It's not as bad
Mhm.
as potentially hazardous ones,
Right.
but it might, and it's good to know more about it.
Yeah. So actually, Friday, November 13th of this year, we actually did have an asteroid that skimmed the top of Earth's atmosphere. And we didn't even know about it until a day later. So this asteroid is known as 2020 VT4, asteroid 2020 VT4, and it's estimated between about 16 and 36 feet. And so Atlas helps us find smaller and smaller asteroids, but it didn't detect VT4 until November 14th. And it was just about 238 miles above the Earth's surface, traveling at a speed of 30,000 miles per hour
Mm-hmm.
over the South Pacific. And so that was when it was the closest approach, and it actually passed at about the same height as the ISS, right? Because the ISS is
About 260 miles. Yes. Yeah.
Yep, yep.
Yep.
So if it had passed any lower, it could have been a really, really bright meteor.
Mm.
And but at its size, I think some scientists were saying it probably would have vaporized anyways. Again, it was only like 16, between 16 and 36 feet or so.
Yeah.
And so the reason why we didn't see it, or we didn't notice, was because of its position was really close to the sun,
Yeah.
and so it was unobservable to telescopes. And so it will actually next visit on November 13th again, 2052.
Oh.
And it's what's interesting about this one too. So we were talking about the types of asteroids. This was actually an Apollo type asteroid, and it had this 549-day orbit around the sun, but because it flew by so closely, our Earth actually messed up its orbit, bringing it down to a 315-day orbit and changing it from Apollo type to Aten type.
No.
And so that was really
That's
interesting.
not good.
And so when Atlas found this asteroid on the 14th, they did kind of so this is what they do when they actually find new asteroids. They'll report it to the Minor Planet Center Near Earth Object Confirmation page, which is this official worldwide organization that collects observational data for asteroids and the like. They calculate their orbits and then they publish the information. And so they're kind of part of the Harvard College Observatory and the Smithsonian Astrophysical Observatory. And their purpose is really just to help observers coordinate follow-up observations of near-Earth objects. So that was 2020 VT4, and we can look out for it again in 2052. Who knows how close it will be then.
Yeah.
All right, and lastly, so those are asteroids that both have not hit us, but we did have one that hit probably 2018. It was a small one as well, and this one was the Kamchatka meteor, and this was a pretty small asteroid, about 36 feet. It actually exploded about 16 miles above Earth's surface, but it had an impact energy over 10 times the energy from the bomb dropped over Hiroshima. And so it landed off the coast, or it actually exploded off the coast of the Kamchatka Peninsula, which is why it's named, back in 2018. And actually, Japan's meteorological agency was able to record the red trail of the meteor against kind of the blue and white background of the Earth, which is really cool. And they said had the burst happened over a populated region, the shock wave would have been strong enough to crack all the windows. And it ultimately landed in the Bering Sea. And it's not related to this meteor, but another meteor that happened in Russia was the Chelyabinsk meteor, right?
Yep. February 15th, 2013, day after Valentine's Day. And that was an interesting one because it really wasn't expected. They expected another one that was closer, that was going to come within the distance of our geostationary satellites, within 2,000 miles of the Earth. So they knew that wasn't going to hit. But this one came in from the sun side, which is more dangerous. And so no one expected this one. And it actually was 56 feet across, and it exploded a couple miles up in the air, which is a good thing. They tend to not be very dense. And there's lots of footage. I mean, this was about 9 in the morning in this Russian city in the middle of winter. So everyone had his dash cam on because when they have a lot of fake car accidents up there. So, you can watch them online. There's dozens of great images of this. So you get the fireball, then you get lots of sonic booms because they're going obviously faster than sound. And actual pieces were found. There was a small crater. I actually touched one of the pieces of that meteor. We have a person named John Wallace. He may actually be on with us next week. He's collected meteorites from all over the world. So I got to touch a piece of this. So the dangerous part about that, it was unexpected, and not a single person died, but there was a shock wave, and 1 million windows were shattered in that city and nearby.
Wow.
1 million windows. Yeah.
Wow.
Yeah.
That was the Chelyabinsk meteor.
Yeah. Yeah.
Did anybody die from that?
Nope, not a single person. And actually, there's a difference between the first wave of the sound and then the shock wave. So people, when they heard the sound, they rushed to the windows because they were either at work or getting to work. And then all those windows broke, and a lot of people had cuts and scratches. If they would have just stayed at their desk or whatever, which is hard to do when you have, sonic booms all around you, but if you would have just stayed there, they would have been okay. But not
Mm.
a single person died, but 1 million windows got shattered just from two types of blasts when something comes in that fast.
Yeah.
But they were very lucky it was 3 miles up. If it had hit, any lower or actually, hit the ground with the entire thing, not just the fragment, there were tons of fragments, of course, they would have been much worse off. And if it would have been a more populated city like Moscow, I mean, Chelyabinsk, I don't know, it's probably not a small city, but it's nothing like Moscow.
Yeah. Yeah. Close call.
Yeah, it was. Yeah. Close call craters. Name of our show.
So, for this last part of today's show, we wanted to highlight a question actually that was sent in by a listener, and I'll read his question. Hi, Sarah. This may seem like a nutty question, but my question is about the meteor impacts at Novaya Zemlya island in the Kara Sea, and the Iceland impact, and what seems to look like an impact at Prince Edward Island, and another here in Maine at Ellis Pond on Route 120 out of Rumford or Mexico, on the road to Andover here in Maine. Webb Lake may be part of this impact structure as well.
Mhm.
My question is there a connection between these impact craters, considering that they are all in the same direction and seemingly have the same trajectory as seen coming from out of space? So, a few things. One, I'm not a meteor expert, but he asked this question from our show with covering Graham Hancock. And so I tried to start from there, but I couldn't really find anything. Novaya Zemlya is actually an archipelago in the Arctic Ocean in northern Russia, and to the west is the Barents Sea, and to the east is the Kara Sea. And the impact that I thought he was referring to was that of the Kara crater, which is actually found on the Yugorsky Peninsula of northern Russia. And that's a 40-mile diameter crater, but thought to have originally been 75 miles in diameter due to just before erosion, and is roughly 70 million years old. But that didn't seem to match up with, because we were talking mostly about the Younger Dryas impact.
Yeah. Yeah.
Um, and
12,800 years ago.
right. But what's interesting is that, Bernie, you were researching on
Mm.
Novaya Zemlya
Yeah.
on another type of impact there.
Yeah, so this was a man-made one, which has a lot of power too, but I'll give you some idea of it, but it doesn't have as much power as some of the natural ones would. So that was the biggest atomic weapon ever dropped. The Russian design is called the Tsar bomb, or the King of the Bombs. It was dropped on October 30th, 1961, and it basically ended all the above ground testing, which is very dangerous, of course. So it was 50 megatons of TNT. It was 1,500 times bigger than Hiroshima and Nagasaki
Wow.
combined. And what I just found out when I looked into it, this Russian person who designed it, he actually could have been 100 megatons. So he
Wow.
cut it in half. There's three different layers, and one of the uranium layers he put in a lead layer to slow it down. This is amazing. It's nice that he cut it in half, but it was still extremely dangerous. The plane that dropped it almost didn't get away in time. It actually had parachutes. They blew it up 3 miles up, so that and they slowed it down so it wouldn't actually hit the ground, even though of course there was nobody there. But it was very dangerous. So they actually could feel heat 200 miles away. There were some people, I guess, in one of those islands, Severny Islands, so they could feel the heat. There was a shock wave for 430 miles. That was
Wow.
window panes were broken at 560 miles away.
Wow.
So like Chelyabinsk times 1 million. It was a seismic on the seismometers. It was a 5.2 earthquake, and it circled the world 3 times.
Wow.
Just a man-made atomic, hydrogen bomb. So some of the meteor, obviously the one that killed the dinosaurs, was like millions of times more powerful. So this is the danger that we created ourselves. It had a mushroom cloud, obviously. It went 60 miles up. It touched basically outer space. That's defined at about 50 miles. So mushroom cloud that touched outer space. It would just, yeah, it would just the most. It was pretty bad, but it was bad enough so that we could then stop making, above ground
Right.
tests.
Right.
We still have a lot of nuclear weapons. We have about 14,000 of them, but nowhere at that level. This
Yeah.
beyond all the levels of anything we've ever created.
Yeah.
So, yeah.
So basically, we didn't find an impact there in that
No.
area that was related in any way to the Younger Dryas event.
Mhm.
And so then he had a couple of other places. Iceland, I
Yeah.
couldn't find one. The only craters that I found there were volcanic.
Yeah. Same.
Um, and then Prince Edward Island, I couldn't find any impact there. And then I couldn't figure out what meteor had arrived here in Maine either.
Yeah. Well, that was actually a potential. I just looked that one up. There are some strange rounded structures around Ellis Pond and Route
Oh, are there?
Hanover. So there are some theories that not and that they could have been that. It's not likely, but it could have been. So what they found was actually pegmatites. So that's an
Oh,
igneous rock. That's the end stage of when the lava dry cools off. Has really large crystals. So if anything, the pegmatite may actually prove that it was also volcanic.
mm-hmm.
It's not like a well-defined crater. It's a theory. There's other places like that, probably all across the country, and there's some of them in Canada that are actually craters from meteorites, but
Yeah.
none of those in Maine. And then Webb Lake, he said it might have been related. So if it was probably, it's not too far from Ellis Pond,
Yeah.
in Dover. So yeah,
Yeah, I mean
okay.
it is important. Maybe we should do a road trip there and take a
Hmm.
look. But there are a couple of things that we can look for to identify an impact crater from other craters. I know you mentioned igneous rock, but again, that could be volcanic. Rocks nearby may have shatter cones, which is kind of like a fractography um, speak of hackles or like straight radial lines, which indicate intense shock, but that would be from a larger impact. So I don't know how big those craters are that you had mentioned. Impact melt obviously is one that you would look for, and then like breccia I think was another, like
Hmm.
basically these agglomerate type of rocks, which are basically rock composed of broken fragments of minerals cemented together. And so there's a couple different types. There's breccia, suevite, and conglomerate, which I'll. But sorry to Mike, we couldn't fully answer your question, but we did try.
Yeah.
You have been listening to Scientifically Speaking here on WMPG with myself and Bernie. Stay tuned for Sports Jam with Cullen and Connor, and from your favorite nerds, mask up, and we wish you healthy bodies and clean air.
Yeah.